All right, so in example 7, we have the integral from negative infinity to infinity of 5x cubed dx. And we want to know whether or not this improper integral is either going to converge or diverge, right? So first of all, 5x cubed is a continuous function. It's continuous everywhere on the real number line. And in this problem, both of our limits of integration here contains the infinity symbol, namely negative infinity and positive infinity. So as long as your function is continuous for all x, namely, again, the entire real number line, you can choose a number, call it c, that in such a way where you can split this now into two integrals. One integral will go from negative infinity to c, and the second integral will go from c to infinity. Right? So in other words, I'm basically using this rule. So just note the integral from negative infinity to infinity of f of x dx is equal to negative infinity to c, where c is a real number, of f of x dx plus c to infinity of f of x dx. One thing to note is that this function f of x must be continuous for all x in order for this note or rule to apply. All right. Well, since 5x cubed is, going back to our function original problem, since 5x cubed is continuous for all x, then all I need to do is choose a value c that will split negative infinity and infinity into two integrals. Well, I'll let you choose. Pick a value. 69? Yeah, you can use something more convenient. Use 0. So you're going to get this integral can be rewritten as negative infinity to 0 of 5x cubed dx plus 0 to infinity of 5x cubed dx. All right, well, 5x cubed, if you take the antiderivative of it, it's going to be 5x to the 4th over 4, evaluated from, well, I should have used a limit statement. I should have said the limit as a approaches negative infinity of a to 0 plus the limit as b approaches infinity of the same antiderivative, 5x to the 4th over 4, but this time from 0 to b. Right? Remember, if it's negative infinity, we use a. If it's positive infinity, we use b. Okay. All right, let's look at the first limit. The first limit would be just rewriting it. We'll get 5 times 0 to the 4th over 4 minus 5a to the 4th power over 4. Well, the first piece, 5 times 0 to the 4th over 4 is just going to be what? That's just going to be 0. So this entire piece is 0. Okay, what happens when I plug in negative infinity for a? Well, first of all, what is negative infinity to the 4th power? Infinity. If I take infinity and I multiply by negative 5 over 4, what would we get? Negative infinity. Very good. So I'm just going to show you what this process, right? So you get negative 5 over 4 times negative infinity to the 4th power. But negative infinity to the 4th power is just infinity. So if I take negative 5/4 and I multiply by infinity, you get negative infinity. Now, what do we know about the first piece? Do we say that it diverges or converges? Yeah, it diverges. And we are done. All we had to show, right, was that we wanted to ultimately know whether or not this integral diverges or converges. Well, since the left half diverges, well, when you're going to do the same thing with the right half, it would also diverge. If you notice, this time we say b is approaching infinity, from 5x to the fourth over 4 from 0 to b. So if you work that out, you would have got positive infinity. So therefore a divergence. No, no, unfortunately, no. No, no. All right, so there's no need to continue. We just say that it diverges.